All right. So let's say we got these three sets. Now remember U, that's significant because it's called the universal set, U for universal. It's just the elements we're considering at this time. In this case, it's a pretty small set, 1 through 10, but it could be various different sizes, but in this case, that's what we picked. U is 1 through 10. All right, so number one for these sets. What would A union B be? Well, union is dumping them all together. It's everything in A combined with everything in B. The union is everything together. And so, I mean, one way to do it is just write that set, write that set. However, let's put them in order. So it's just everything in A combined with everything in B. So what do we got? 1, 2, 4, 5, 6, 8, 9, 10. So we've got quite a bit. Good with that? All right. Now, they can get a little trickier. All right, so we haven't done a complement here. Throw in a complement with it. A complement, intersection B. So this is union. The upside down one, that one's intersection. So first thing, intersection is, what does that mean? It's what they have in common, right? Intersection is what they have in common. So I'm looking for what they have in common here. Now, the thing is, the first set is A complement. I suggest if we're dealing with A complement, let's write it out. What is A complement here? Well, if A is 2, 4, 6, 8, 10, A complement is what's not in A compared to the universal set. So that's where the universal set comes in here. So if A's got 2, 4, 6, 8, 10, which that's the even ones, what's A complement got in it? The odd ones, yeah. So A complement would be 1, 3, 5, 7, and 9. Right, because A's got all the even ones, so A complement would have all the odd ones in this case. All right? Okay, so now it's a little easier to compare. So we want the intersection of this and B. So the intersection is what they have in common. So what do they have in common? 1, this one and this one. 1, 5, 9. Everybody good with that? Both of them have 1, both of them have 5, both of them have 9. That's the only ones they have in common. Okay? All right, third one on this, let's do B. Let's do it a minus one. B take away A, B minus A. So again, my suggestion is start with this one. Whatever the first one is, start with that one. And I did just a basic one. I just said let's start with B. So in this case, B is 1, 4, 5, 6, 9. All right. Now I take away A, so take away any that are in A. Which ones do I take away in this case?
6.
Take away 6.
4.
6 is an A. 4 is an A. I'll take it away. 1's not an A. 5's not. 9's not. So yeah, you wind up with 1, 5, 9. All right. Is that right? Everybody good with that? Yes? All right. Now this one, a little bit trickier because on these set operations, we can have more than one set operation in a particular problem. So this is one of those. All right, so let's do it. Let's do B complement intersection A complement union B. B complement intersection parentheses A complement union B. Any guesses on what we do first? Parentheses first, yeah. Parentheses always come first in mathematics. That's the way we distinguish those. So we're going to do parentheses first. So let's do that. So in this case, I'm going to do this set. So my suggestion is let's just work our way down here. Let's put this set together here, which is going to be a pretty big set. All right, now, it's A complement union B, and so here's A complement right here. Here's B. I already used those two sets, but now I'm union those together. Union, we put both of those sets together, right? All right, so if I put both of these sets together, everything in this combined with everything in this, what have I got? 1, 3, 4, 5, 6, 7, 9. That's what the union of those two sets are. Now, I take that result and intersect it with B prime or B complement. Well, again, my suggestion, if you don't have it written down, I would write it down. What is B complement here? Well, again, the complement is everything that's not in that set compared to the universal set. So what's not in B here? 2, 3, 7, 8, and 10. So I'm going to take B complement, this set, and you need to write it down here, that's fine. So I take this set, compare it to this set, and I want to intersection those. What's in common of those? So what's in common between this set and this set? Well, I got 3 in common. I got 7 in common. That's it, isn't it? That's all that's in common. I got 3 in both. I got 7 in both. That's it. Okay. Three and 7. Question? Good with that? All right. Number 5 here. A lot of mileage out of these 2 sets. One other little quick point here. What if I had a complement on the outside of the parentheses? What do you think that means? Well, one way you look at it, parentheses first. So what do I do first here?
The A.
Do the A intersection B first. This is in the parentheses. So A intersection B, if I expand that out to be what it is, A intersection B is what A and B have in common. And so A and B have in common, they have 4 and they have 6. That's A intersection B. Right? Yes? Now, I do the outside. Right? Inside first, and then I do the outside. Now I complement that. Well, the complement's just what's not in there compared to the universal set. What's not in 4 and 6? There's a whole bunch. Compared to the universal set, what's not in 4 and 6? 1, 2, 3, 5, 7, 8, 9, 10. Right? That's what's not 4 and 6. It's everything else. Okay? So if you have that complement on the outside, do the inside first and then do the outside. Now, a little different problem here that it will also ask you to do. So it's number 6 on this. Let's place the elements in a Venn diagram. So place these elements in a Venn diagram. Maybe make it a little bigger here. All right, so we've got A and B sets. And I just want to place those appropriately. Now, the thing about what that means is there's only one spot for each element. So the universal set, usually designated on the bottom, or, well, I guess it matters, but do you see there's 4 parts to this Venn diagram? If you think of it like a puzzle, if I was going to cut this out and make it into a puzzle, I'd have the moon shape of A, I'd have the middle between A and B, and then I'd have the moon shape of B, and then I'd have the outside part. So there's 4 parts with me. Okay. Well, so let's just start. The elements I'm placing is everything in the universal set. However, set 1, element 1, where would it go? Well,
Thank you.
1's here in B. It's also the universal set, but I'll talk about that maybe more later. But 1's in B, but it's not in A. So you see, the only place that could go is out here. It's got to be in B, but not in A. Okay? So 1's out there. What about 2? Well, 2 is in A, but not in B. So the 2 has got to go out here, the moon shape of A. Now what about 3? Because I'm going 1 through 10. I got to do all of these. Where does 3 go? It's not in A or B. It's got to go on the outside, doesn't it? Somewhere just on the outside. What about 4? It's in both of them. Where would it go? It's got to go in both of them. I can't put it here and here. Like I said, each element only goes in one spot. It's got to go right in the middle, yeah. That middle part is in both A and B. So if I've got one that's in both A and B, that's where it's got to go. And then the rest, that's the 4 basic things that could happen. All right, 5 is in the B only, so it goes out here. 6 is in both, so it goes in the middle. 7 is not in either one, so it goes on the outside. 8's only in A, so it goes somewhere in A, moon shape there. 9's only in B. 10's only in A. All right? So each element just has one spot, and I stop at 10 because that's our last number in the universal set. Question? All right. So I'll have a couple of those for you to do. Now let me do sort of the same thing, but let's get 3 sets here. Universal set and then 3 sets. All right. So in this case, let's do 1 through 12 for the universal set. Universal set can be whatever we want it to be. In this case, we'll go up to 12. All right, let's say set L is 1 through 6. Set E is even ones, 2, 4, 6, 8, 10, 12. And then set T is 2, 3, 5, 8, and 12. All right. So let's do the same sort of thing we were doing with the A and B sets. But let's do these. Let's start with L union parentheses T intersection E. Kind of start easy here. Well, we've already talked about parentheses first, and so we would go with T intersection E. Like I said, I would show your work here, so test purposes, partial credit. I kind of know what you tried here, if you missed it, but anyway, parentheses first. So I do T intersection E. Intersection's what they have in common. So what do T and E have in common?
2 and 8 and 12.
2, 8, and 12. Okay? 2, 8, and 12. Now, I take that result and union it with L. So, like I said, I kind of made it easy this first one here, but yeah, what is union? Everything in both put together. So everything in L combined with everything in this 2, 8, 12. So what have I got? Everything in L, so I've got 1 through 6, and then combine that with the 2, 8, 12. 1, 2, 3, 4, 5, 6. Everything, that'd be everything in L. And then this contributes the 8 and the 12. I've already got the 2, so I don't have to write it in.
8. Yep.
So put the 8 and the 12 on the end there. Good? All right. Now let's do one that's a little bit longer, I guess I'd say. All right, so number 2 on this, let's do L complement intersection T complement, that's in parentheses. And then intersection L union E complement. This one's got 2 parentheses, so do what's in parentheses first. Maybe I should have moved it over here because, let's move it over a little bit. So I can make some other sets here. Okay. All right, so this one involves the complements. So I would write those down, because it's easy to leave something off. So I've got all 3. So let's just do the complement of each set here alongside each set. So the complement's what's not in there. So L's got 1 through 6, so L complement would have the rest of them, 7, 8, 9, 10, 11, and 12. E complement would have what's not in E. E's got the even ones, so E complement would have the odd ones. So it'd be 1, 3, 5, 7, 9, and 11. And then T complement has what's not in T. I don't know how to describe set T, but T complement's what's not in there compared to the universal set. So I don't have 1, so that's in the complement. I don't have 4, 6, 7, or 9, 10, 11. Those are my complements. I'll write those down. Okay. All right. So parentheses first, back to our problem. First one we got is L complement intersection T complement. Intersection is what they have in common. So L complement intersection T complement. It's what these two have in common. Top one and the bottom here. Be 7, 9, 11, wouldn't it? 7, 9, 10, 11, sorry. With me? 7, 9, 10, 11? Now, a little trickier on this one. We also have in parentheses, on the other side, L union E complement. So here's L. I want to union that with E complement. But I'm unioning, so it's what they have in common. I'm sorry, everything in both put together for union. So they both, we're going to put 1 through 6. I know we've got all those in there. Then I've also got anything else in this one? 7, 9, 11. So that's the union of those two sets. So just work your way down. Now, those results, I intersect them together. So that's just what's in common here and here, so we got 7, 9, 11. Okay? All right. Any questions about that? All right, well, let's do this one. Also, place the elements in a Venn diagram. All right. The thing about this Venn diagram is I've got the universal set, but how many other sets do I have?
3.
I got 3 other sets. So instead of just having 2 other sets, A and B, I've got L, E, and T. So let's do it over here so I can make it. All right, so the rectangle, that is the universal set. I've got an L set. I've got an E. But then I also have a T. So I need a third set. Well, the thing about that, yeah, L and E could overlap, but so could T with the other 2, right? So I better draw it where I'm interlocking with those other 2 sets. That may not be big enough yet, but with me? That's how I put that third set on there. All right, so we go through this. So L1, start with 1. 1 is in L, but it's not in the other 2, so it would go out here, right? And what about 2? It's in all 3. Where does that one need to go? Right in the middle. So the intersection of all 3 is right in the middle. When an element's in all 3, it would go right in the middle. Now, here's a little tricky one. 3 is in E, L, and T, but it's not in E.
So put in L and T.
It goes in L and T, but it can only go in one spot. So it goes in the middle with the L and T, but it's not in the very middle, right? It's right here. Ah, yeah. 4 is only in L. 5 is in L and T, so it also goes there with the 3.
4 is in E.
4
is in
did I miss
L
it?
and E.
I was just checking. 4 is in E, I'm sorry. 4 is in L and E. So where would it go? Between L and E, but not in the middle, very middle. Is that better? I was just checking. Okay. 5 in both. All right, so 6 is in L and E, but not in the all 3. What about 7?
Outside.
It's in nothing, so it goes on the outside. 8 is in E and T, but not in L, so there, right? 9's not in either, any of them. 10's only in E, so go there. 11's not in any of them. And then 12's in E and T, but not in L. You with that? Do that right? Okay, so it's a little trickier when you get 3, but not too bad. Any questions on that one?